So today we are gonna see about our linked list, and all some other operations with our linked list. So first for our linked list, let me create a package. Let the package be linked list. And before going to the programming stuff about what is actually a linked list. So earlier we have seen an array list. Okay, we also know our regular list. So when you are coming to the linked list, what is a linked list? Assume that you have a node. Okay, this node will be having the address of the first element of the linked list. Okay, so whenever the linked list is called, this node will be called first, and this node will be mapped to the first element of the linked list. In this element here, you will be having the value of this. Okay, of this node you will be having the value. Here in this place you will be having the address of the next node. This will be your next node. This next node will be having the value of this correspondent address. Okay, if there is no linked list over here, that means there will be no address. Only if you are having another linked list, you will be basically having a link and you will be having a address over here. Got it? Every linked list node will be having two parts. One will be your value and the other one will be your address. This address will be present only there if there is an another attachment, if there is another element, or else there will not be any address. This is how our linked list will work. Okay, are you understanding the basic structure of the linked list?
Yes, sir.
Yes, Monish.
This will be your basic structure of our linked list. So now let's come back to our program. Let's see how we actually code a linked list. So let's write a class. Let the class name be demo, or let the class name be link. So our linked list class will be having a main method. In this main method, I am creating a linked list. So this will be my linked list. So linked list also is same as the array list. So you create an object for it and then you create a linked list. That's all. Everything is the same. Okay. So now what are the operations in it? So operations also are the same. You can directly add something over here. So let's add some names. So this will be our name 1. I'll just copy this and paste it. So here let the next name be Nitin. Here the name be Pujita. Here the name be Hemalata. So these are our 4 names. So for printing these 4 names, obviously we'll take up a method and we'll say get all names. This will be taking a linked list, okay, of type string, and that is a list. Inside this we normally write a for loop. So for loop of string, and let the string be names, sorry, not names. Here the linked list name is a list, and then you simply print out the name. So in this method itself, I'll simply put up a separator instead of writing separator again and again. So here what we need to do, we need to create an object for our class is equal to new link. Now link dot get all names of names. So now when I run this, basically you will get all the names and you will get a separator. Yes or no? Till now everything is the same, right?
Yes, sir.
So now we are basically, when we are talking about the linked list, we are talking about the address and the value. Means in case if I want to add to a particular position, I can add an element to a particular position over here, and then I can just print everything out. This is possible in linked list. This is possible even in the array list also. There is no speciality over here. Okay, both are the same. You have a normal linked list. There is a small difference why we are using a linked list, why not an array list. We'll come to that when I am going on with the list interfaces. Okay, let's see some other linked list operations. So here we are adding. So adding is good. So if I want to remove, so I have a method called remove. So here that it is not asking me to specify a index position to remove. So what will it remove? Will it remove the first element or will it remove the last element? That is the question. Okay, so let me print it out. Let me print out all the elements of our names list and see whether it is removing the first element or the last element. So if you see now here, which element is being removed?
First element.
The first element of the list is being removed. So when you directly use the remove method, the first element will be removed. You can even specify a index. Even that is possible in our remove method, where if you specify a index, that particular index will be removed. Here our second element was Nitin, so Nitin was removed. Clear till this point?
Yes, sir.
Okay, now you can even set some values over here. So set value means it is basically used for modifying. We already did everything in array list with the help of some methods. I don't want to create any methods over here. So instead of creating methods, I am simply writing here itself. So the second index, whatever it was there, I changed it to Java. Now if I run this, let's see what happened. So first we added array, then we removed Nitin, the second element. After that, our second is now become Pujita. Pujita has become Java. Okay, very appropriate. So that is what we are setting. Good. Did we did our complete CRUD operation over here?
Yes, sir.
Okay. Now, is our linked list part of collections?
Yeah.
Our linked list is basically a part of collections. So let's call upon our collections class, and then in our collections class let us sort it. Okay, I'm sorting my names list with the help of our collections class. Okay, now let me just get my good. Now if you see over here, everything is sorted in the form of alphabetical order. Got it?
Yes, sir.
Okay, this will be basically our sorting with the help of collections. Okay, the same thing we can even do a reversal also. So names dot, we have a method called, no, we don't have a method called a reverse. Let us see. Yep, here we are basically having a reverse method in our collections, where we can basically reverse everything. So after sorting, ARY was first and Monish was last. Now what happened? Monish is in the first, ARY is in the last. Okay, so that is our reverse method. So now the problem is, do I need to access collections for sorting? So is there not any other way to sort? There is another way to sort. Okay, so here basically I'm giving null for now. Don't worry about what is this null. Okay, we will see what is this null in a minute or so. For now, just assume that I am giving a null. So first of all, what is this value? What is it taking is the question. So it is taking a comparator. Okay, what kind of a comparator you want to give? Okay, that is basically a part of our list interface. So we'll go there soon, but before that, for now I want to just give it as a null. After null, I want to sort it. Sorry, I want to print it. Dot get all names. If you see over here, now with the help of our names also, we are sorting our complete linked list. Done? Understood?
Yes.
How we are running our linked list?
Yes.
No changes. There are not a lot of changes. Everything is as same as our normal array list, right? Any doubts on linked list, or can I go to the next part?
No, sir.
Should I go to the next part or not?
Yes, sir.
Okay, we'll go to the next part, where my next part will be list interface. Let me create a package and let me say list interface, and then let me create a class and let me call that as li. Okay, shortcut for list interface, and let me create a public class. Okay, now before going into whatever that is, I'm just gonna copy this, my linked list, and I'm gonna paste it over here. Okay, now I'll want to go to my collections where I'm having my array list. So basically this was my array list. Let me go to boxing. Do I have a array list in boxing? Okay, I'm not having a array list in boxing, so I'll copy this from over here. Let's go close everything. Let's go back to my list interface. Let me copy this, and here let me add a array list of type string. Let the name be demo. Let it be names for now. Let it be new array list. Now here let me select everything. Let me go to refactor, rename, let me make it demo. Okay, so everything is changed. Got it? So I have created a linked list and I have created a array list. Nothing which is unusual. Everything is the same. Till now, no doubts, I'm presuming.
No,
Yes or
sir.
no?
No.
Okay, so now let me go back to my linked list, and inside this linked list I'm having get all names. I'm gonna copy this method also, and then I'm gonna paste it over here. Control Shift L, formatting, done. Okay, now let me once go to the list interface. Okay, the first important thing is the list interface is implementing all these classes. Okay, in this you are already having a array list and also you are having a linked list, right? So basically our list interface is implementing these two classes. It is implementing our array list and it is implementing our linked list. It is a part of collections and also it is a part of iterable. So what is iterable, what is an iterator, we'll see in a minute or two. But for now, our list interface is basically implementing the array list as well as our linked list. So keeping that point in mind, what I'm going to do is, instead of writing the linked list or array list over here, I'll make this as list interface. Okay, I made this as my list interface. Now let me create an object over here. Let me say that this will be li space li, which is equal to new. Okay, I don't want even to create an object over here. I'll use my anomalous class method, which is my new li dot get all names of names. Okay, I hope you know this method. I'm not creating an object, I'm directly using the anomalous class. Okay, that means I'm directly using the constructor and I am calling up my get all names method. So in this, here I am mentioned as list, and this object is basically running for names, which is my linked list. Okay, and I am running this. Am I getting all my names or not? Basically,
Yes, sir.
Yes,
I got
Monish.
all my names. That means that whether it is a list, whether it is a linked list or an array list, it doesn't matter, because they both are implemented with the help of list. Okay, now here also I'll create a new li dot get all names and I'll pass my demo. My demo is basically an object of array list, and when I run this, then also I'm getting my output. So basically I don't have any issues whether I run it over a array list or a linked list. Now the very simple question is, if everything is same, then why do I need to use my linked list and why do I need to use the array list? What is the difference between these two? Remember, when we were using our array list, when we remove an element from our array list, what happens? Our array list collections framework is basically creating us a new array list. Means the memory is more, but array list is fast. So if you want to do it fast with lot of memory, then you will be using a array list. Linked list is basically slow, but it will not take any memory. So when we are taking a lot of memory, the array list is fast. So at that time we'll be using a array list. But here, when you are using a linked list, the process is slow, but it will not take a lot of memory. Understood? So this is why we need to use a linked list or why we need to use a array list. The only difference over here is array list is array list is fast, but it will consume a lot of memory. But linked list is slow, but it will not consume a lot of memory. This is why we have to use linked list and why we have to use a array list. But the question now is, when I have to use a array list and when I have to use a linked list. That is the question. So let me put up a points. Why array list? This will be our first question, and the second question will be why linked list. Okay, array list time is fast, space is more. Okay, you can simply say as memory taken is more and time or the execution time is fast. Okay, But when you're talking about the linked list, what happens is the execution time is slow, but the memory taken is minimum. Okay, this is basically our why array list and why linked list. Now the question is, when array list? When should I use a array list and when should I use a linked list? This is the question. So when do I need to use a array list and when do I need to use a linked list? Since this is taking a less memory, okay, so when you are performing more number of operations, we will be using a linked list. Basically, operations will be our set method or remove method, delete method, these kind of things. When there are more editing and all, when there are more, we will be using our linked list. But when you come to an array list, when there are less operations and more searching, we will be using the array list. If you remember, when I was explaining a array list, I even told you how to search an element in the list, but I have not used that searching method even in stack or even in our linked list, because for searching, array list is the best. For operations, linked list is the best. Okay, when we need to use the array list, when we have searching is more, you use a array list. When your operations are more, we use a linked list. Are we clear till this point?
Yes, sir.
Okay, understood what is happening over here?
Yes, Monish.
So when we are basically running our inheritance, we told that when you are having an inheritance where it is basically our ISA relation, when it is ISA relation is basically accepted, we write our main parent class name over here and we create an instance of the child class over here. Now the implementation is also the same. So what we do is we will write list over here and we'll write a list over here. There is no need of mentioning whether it is a array list or a linked list. You can create an instance for a list and you can run. You will not get any kind of errors. Okay,
Yes, sir.
are we clear till this point? Any doubts?
No, sir.
No doubts, but your voice is very doubtful. Yes or no?
No doubts. No doubts, sir.
Okay, fine, if you say so. So let's go to our next topic where we'll be doing our iterables, okay, or our iterators. So iterators, I'll simply explain you in the linked list. Okay, so before we used to run a for loop, right? For each loop, we call this as for each loop. For each loop is basically a perfect example of our iterator. Okay, whenever you are running an iterator, basically what happens is internally a iterator is whenever you are running a for each loop, internally the iterator is running. Okay, so instead of a for each, we'll directly create a iterator right now. So when you want to create a iterator, you will simply write iterator. Okay, iterator is also a interface. Do remember that iterator is taking a string. So iterator is equal to list dot iterator. So that will be your object creation for iterator class. Okay, then we will be saying while iterator dot has next. Here has next is a method where it is checking whether the next whether the next row or the next item in the list is present or not. If that item is present, then you will go to the you will go inside the while loop and you will simply write print whatever you want to print, iterator dot next. So dot next method will give you the current item of that row or current element in that list. Okay, has next will return true or false. If it is having the next line, it will return true, or else it will return false. Dot next method will return the current element. Okay, are we clear? So now let me just simply run the link class. You are seeing that we are getting all the outputs as it is. There are no changes. Got it?
Yes.
Got it? How we are running the iterator? I'm asking you, did you get it or not?
Got it.
Yes or
Got
no?
it, Monesh.
Okay, fine. So let's go to the next topic. Next topic will be our compare to. Compare to is a method and a very important method. Okay, let me create a package called compare to. Let me create a class and let me say comp. Okay, so what is this compare to method? Compare to is basically a comparator. It's a method for comparing two things. So how is it comparing? The question is very simple. How is it comparing? So let me take two strings. String x, which is equal to a. Okay, string y, which is equal to b. So the thing what I want to do over here is I want to compare these two. So with what I want to compare? I want to compare x with, I have the method compare to, and I want to compare it with y. So when I run this, what is my output? It is giving me -1. So the thing over here is the values, how it is giving -1 or how it will now give 0 is the important part over here. Okay, let me put out an example. First of all, just understand one thing. Okay, that one thing is here. Sorry about that. Let me clear my complete thing. Okay, now in this code there are two parts. Part 1 is before the dot, part 2 is inside the compare to method. So part 1 will be our before the dot whatever we are having. Here I am having a x. Okay, that is here x is my part 1, and part 2 is whatever I am having inside my compare to method. Okay, that will be my part 2. Inside the compare to method I am having my y. Okay, that is my part 2. So assume that this is part 1, this is part 2. Okay, if part 1 is equal to part 2, then my compare to method will basically give it will return me 0. Okay, at the same time, if my part 1 is greater than part 2, it will give me any positive value, not only one. It will basically give me any possible value. Okay, here if it is part 1 is less than part 2 or part 2 is greater than part 1, at this time it will give me any negative value. not 1 or not -1. It may give me any positive value. At the same time, it may give me any negative value. Are you and people understanding this?
Yes, sir.
Okay, let's go back to our index. Here now it is a and a. When I run this, obviously we'll get 0. Okay, now if my part 1, that is my x value, becomes c, and if I run this,
1.
not 1, you will get any positive value.
Okay, okay.
So here I am getting 2. Okay, don't assume that for a and c you are having two different, so you are getting 2. If I put some x variable over here, now if you run it, you may get 23. Okay, so it will basically give any positive value, not 1 or not 2. It may give you any positive value. In this case, if I make my part 1 value as a and part 2 value as some alphabet, here it is g. Now you can see over here the result is -6. So it will basically give me any negative value. The one thing you need to understand over here is part 1 and part 2. If both are equal, then it will basically return me 0. If part 1 is greater than part 2, it will basically give me a positive value. If part 1 is less than part 2, it will basically give me a negative value. So that is for strings. But what if I have a int? It is already starting to give me errors. Okay, now see over here, it is giving me an error, cannot resolve method. So what is the problem over here? Int x equal to 3, int y equal to 4, those two are legitimate values. So comparison though between those two are possible. But the problem with our compare to method is it can't run over the primitive types. If you want to give an integer, you must tell it with the help of the wrapper class. Now if you see, there is no error. Even if I run it, there will not be any error. It will give me -1 because 3 is less than 4. Understood? What is a
Yes.
compare to method?
Yes, sir.
So this compare to method is a part of an interface called comparable. Compare to method is basically a part of comparable. Okay, so our next topic in our list is our comparable interface. So let's see what is this comparable interface and what it will do. Okay, so what I'll do is I'll simply remove this. Okay, now to run our comparable, I'll simply start creating a class over here. Let the class name be names. I have a class name called names, and class name is implementing my comparable of type names. This is my class. Okay, so let's just wait for a second about our unimplemented methods. First, let us create what are all the things we need inside of this. So for now, I need a private variable which is basically a string, and I am calling this as name. So this name, let me create a constructor first, a constructor with field, and then to retrieve the name value, let me generate a toString method. So let me make some small changes. I don't want this flower brackets and all, so that is part. Okay, and then let me remove this. Yep, now I'll get only my name. So until that is enough. Okay, so now let me unimplement implement my unimplemented methods. If you see over here, we are having our compare to method. Okay. Now the thing is very simple. I want to compare these two based on the length. Okay. So first of all, let me create a list of elements in my main method so that I can compare with the help of my compare to method. So I'll create a list which is having a string and I'll call it as names, which is equal to new a linked list. Let me create a linked list. Okay. So in this linked list, I'll add some elements. So and now let me just copy this, paste, paste, paste. So here let it be Hema, here let it be Pujita, here let it be Latha. So Monish is having 7 letters, Hema is having 4, Pujita is having 8, and Latha is having 5. So if I basically want to sort this, if I directly use my sort method from my collections, what will happen? If I directly use my sort method, what will happen? Come on guys, tell me what will it happen? Are you people alive?
Yes, sir.
Thank you. First of all, let me create a get all names method. So this get all names is basically taking a list of strings and let it be list. So inside this, what do you want to use? Do you want to use a iterator or do you want to use a for each loop? Let's use a iterator.
Iterate.
So iterator of type string. No, I want to iterate over names, the class. Whatever names I want over here, I want to iterate over my names from my class. So whatever I'm getting, I'm passing it over there, and let this be iterator, which is equal to list dot iterator. So while now see over here, it is giving me a type error. So let me make this also as names so that there is no type error. So iterator dot as next. Inside this, let me print out iterator dot next, and here let me put up a separator. Done. Till now we got everything from this. Now let me create a object for my class. Done. My object is created with the help of my object con dot get. Done. Okay. If you see over here, it is giving me an error because of what? Because my list will take names. It will not take this. Yes or no? Come on guys,
Yes.
speak up. So now the question is, how do I get it? First of all, I added everything to names with the help of my linked list, not with the help of my names class. So first thing what I want to do is, I don't want like this. I want to add it with the help of my names class. Is it possible to do it like this? Done. Is it possible, guys? Tell me, is it possible to do something like this?
Don't know, sir.
Oh no. You are using a constructor to set some values.
Yes.
That is not possible. Tell me, is that possible or not? Did we do boxing?
Yes.
We did boxing, right?
Yes, sir.
So this is
Yes,
not
Monish.
boxing. This is boxing, right?
Yes, sir.
Then what is new over here? I did my boxing. Instead of a string, I am passing the generic type names. Okay, don't worry about generics. We will go from the next session will be on generics, so you'll understand more about it. But just understand this: instead of the list of strings, I am passing list of names. Okay, whatever names I
Okay.
want to add, I am adding it with the help of the constructor. I am boxing it. Okay, I am not using auto boxing. I am using boxing methods. I am boxing it. Okay, now with the help of my object I am calling my names, no errors. And if I run this, you see here I am getting my names. Okay, everything is Monish, so everything is like that. So let me put our names, whatever we thought. Sorry, so we thought about Hema, we thought about Pujita, and here we thought Lata. Now if I run this, see, no errors, right? We are getting everything properly only. We are
Yes,
just
Monish.
boxing. We are not doing anything extra. We are only boxing it. Okay. Now let me write. With the help of my collections method, I want to sort this names. After sorting it, with the help of my object, I want to get all the names. Okay. So here, if you see now, how is it? Did it sort anything? Did it sort?
Yes, sir. No, sir.
But basically it
No.
has to sort, right?
Yes, sir.
So why is it not sorting? Because sort method is basically taking a parameter where that parameter is sent to our compare to method. With the help of comparison only, right, our sorting will happen. You need to first compare whether A is greater than B or H is greater than M. Then only it will return you something. Here I am telling you to return 0. Means I don't want to return anything. However it is, I am telling you to return it in the same way. So it is returning it in the same way. Okay. So we need to write our logic over here. We are tweaking the logic. So here I am simply saying if the original name dot length is equal to the names is referenced with an object O. So I'll put O dot name dot length. If this is happening, I'll say return 0. Else if, what is it, name dot length is greater than O dot name dot length, if that is the case, then I am telling return 1. That is what our compare to method does. At the ending, I don't want to write any case and I want to simply put a -1. Now if I run this, now did it sort it? Yes or no? Did it sort it or not?
Yes, sir.
That too, it is sorting with the length. Okay, it is sorting with the length, not with the alphabets. See over here, Hema is having 4 characters, so it is in the beginning. Lata is having 5.
5.
Monish is having 7.
7.
Pujita is having 8.
8.
Okay, so it is sorting in the ascending order. So if I want it in the descending order, I need to just put -1 over here, and I need to make this as +1. And if I run this, it will basically return me a descending order.
Okay.
Got it? So
Yes, sir.
basically
Okay,
our
Manish.
collections.sort method over here is taking the values to the compare to method, and it is comparing over here. Okay. Before we didn't override our compare to method. So our collections.sort method basically sorted everything. But now I am overriding my method. So I am giving my values. I am tweaking the complete compare to method. That is the use of comparable, a interface where it is having a method called compare to, where I can basically tweak my sorting algorithm. I can sort it with the help of the names, I can sort it with the help of the alphabets, with the help of numbers, ascending, descending, whichever sorting mechanism I want, I can do it with the help of the comparable. Are we getting it?
Yes, sir.
Okay, let me just, that is end of the session for today. Okay.
Okay, sir.